And if you can tell me what we learned about yesterday. Kaylin.
Factor trees.
Factor trees, awesome. And your target today was to create a factor tree of the number 72, okay? What two numbers multiply together to get 72? Yes?
2 times, 8 times 9.
8 times 9, awesome. So she thought of two numbers that multiply together to get 72. So we're going to write it up here. 9 times 8. Okay? Are those numbers prime? No, they're not prime. They can be broken down further, right? Remember, prime numbers are just divisible by themselves in 1. So David, what can we do to the number 9 to break it down even further?
We can put 9 times 1.
Remember, we're trying to break it down to numbers except themselves in 1.
3 times 1. 3.
3 times 3, very good. All right, and how about the 8? Kashmir. 4 times 2. Can that be broken down further? Kanaja, what do you think? 2 times 2 is 4, very good. And what is the little trick we do at the end of the factor tree? Mario? Circle all the numbers so that we know that those are the prime factorization of our original number. Okay? Well, there are other ways to do it, that's right. But eventually they're all going to break down to their prime numbers. Okay, what we're going to do is we're going to take that knowledge that we learned yesterday about prime factorization, and we're going to learn how to find the greatest common factor. Raise your hand if you can tell me what the greatest common factor is. Actually, put your hands down for a second. We're going to get to that in a minute. Why don't we see if we can do factor trees as students in a group, okay? So raise your hand if you'd like to be a volunteer. Marvin, come on up. Marvin's the number 63. Just one we're going to practice with. You can stand up right on top of this chair. We're going to build a human factor tree here. What two numbers multiply together to get to 63? What two numbers multiply together to get to 63? Hernan.
7 times 9.
7 times 9. Awesome. Can I have 3 volunteers? Adea, Yesha, and James. If you could stand right in front of them, 7 times 9, just like Hernan told us. Alright, keep it up high, alright. Now, can these numbers any of these numbers be broken down even further?
Yes.
Raise your hand. Jesse,
Yes.
which number?
9.
What two numbers can multiply together to get 9?
36.
Awesome, awesome. Can I have 3 volunteers? Cheyenne, Elon, and Stuart. 3 times 3. If you could kind of kneel down in front of Adea. You guys are the bottom of my human factor tree. All right, so we have another number up here. I'm going to ask for another volunteer to stand up top on the chair. Can I have Rayshawn? And David, tell me 2 numbers that multiply together to get to... Yeah, right, stand up right there. Tell me 2 numbers that multiply together to get to 49.
7 and 7.
7 times 7, awesome. Can I have 3 volunteers? Josh, Ramalis, David, come on down. Alright, now we're going to use these factor trees that we just learned about yesterday, and we're going to find the greatest common factor. What we do, you guys, is we got to find factors in common from both of the original numbers. Looking at those factors, which ones do you guys see that are in common with one another, that are in both green and blue? Kate?
7.
7. Do you see any other ones? No? So guess what, you guys? The greatest common factor is, everybody?
7.
All right, thank you. You guys can have a seat. Awesome. All right, we're gonna watch a quick video. It's got a song on it that reviews the prime factorization and kind of talks about how we can use prime factorization for finding the greatest common factor. While that is coming up, I want you guys to talk with your neighbor about how we determine the greatest common factor using factor trees. Go.
We have to make sure that the last number that we have to enter we have enough.
So what do you like to share?
See which ones are in each one, and then that then we multiply them.
Sorry, I said last number.
All right, everybody stop. All right. This song kind of reviews what we just went over. So if you guys could watch for a moment.
Special type of numbers, only factors are one in itself. Factor down a tree.
You guys can sing with it if you want.
Strange to me, everyone come to me. Break down the number, please. Factor down a tree. Number 9, branch it down with primes. Is it 3 times 3? They also prime. 3 times 3, circle them for me. Yeah, I can see a factor tree. Factor down the tree.
Break the number down for me. Branch it out to 2s and 3s. Come on, you guys.
Circle all the primes for me. Factor down the tree. Number 12, branch it 3 times 4. Then I'll circle the 3, branch the 4. 2 times 2, you know just what to do. Yeah, 3 and 4, circle those 2s.
Factor down the tree. Break the number down for me. Branch it out to 2s and 3s.
Circle all the primes for me.
Factor down the tree.
Simplify if powers are dry. You can square a cube, all like primes. 24, branch it 6 times 4. Now it's 3 times 2, 2 times 2.
Factor down the tree. Break the number down for me. Branch it out to 2s and 3s.
Circle all the primes for me. Factor down the tree.
I need for everybody to raise your hand if you feel good about using factor trees for prime factorization. All right, if you got your hand raised, fist bump a neighbor. In 30 seconds, just review what we just went over with your table. Go.
That the number just okay.
All right, everybody stop. All right, we are going to talk a little bit about greatest common factor. Greatest common factor is the biggest factor that two numbers share. Okay? Can anyone figure out the GCF, or greatest factor, the biggest number that the following numbers share in their head? We're going to try mental math on this. 12 and 42. Raise your hand if you can think of it. David, what do you think?
2.
That is a factor for both of them, but is it the largest one? 6. 6 is correct. Okay? 6 times 2 is 12. 6 times 7 is 42. It is actually, if you would do the factor trees and break it down, the prime factors, and then put them together, we would determine that the greatest factor, the GCF, is 6. Okay? Prime factorization is the process we've just been using to get to this point. Okay? We are going to use that process to circle the common factors for both of the numbers. Okay? We're going to identify the common factors. So, 27 is 3 times 9. We know that 9 is not a prime number, so we can break it down even more, just like our target example. We circle the 3, and we have 3 times 3. We're going to circle all the ones at the bottom. Okay? So we know where we're at. We got 27 down to all of its prime numbers. We're going to do the same for 36. Okay, 36. Whenever it's even on the end, you guys, you can always use 2. For 36, you could have done 6 times 6, but sometimes it's hard to remember what the biggest factors or larger factors are. So if it's even, you always want to use 2 if you're not sure. Okay? So then you can break it down even further. 18 is 2 times 9. We circle the 2's. And 9 we can break down even further. 3 times 3. We circle the 3's. Alright? Now what we're going to do is we're going to look at what the common factors of both of them are. Which ones do you guys see that are in common in both of them? Cheyenne?
3.
3's. How many of them? You see a 3 here.
5.
There's 1 here. Well, there's 5 total 3's up here, but we're only using the ones that both of them have. How many do both of them have?
1 has 3 and 1 has 2.
So we know the 36 only has 2 3's in it, so that's the most we can use. Okay? So to find the GCF, we're just going to use those 2 3's that they have in common and do 3 times 3, so the greatest common factor would be 9. You guys understand how we did that?
Yes.
Alright? Well, you guys are going to try it now. I want everybody to, actually I'm going to pick a volunteer from each table. You're going to look underneath your table. There are going to be a few problems there. And you're going to use the dry erase, wait, just hold on a second. I'm going to pick a member from your table to look under the table. You got problems under there waiting for you. You have dry erase boards and markers and paper towels, and Mr. Tyler and I are walking around, and we're going to try and figure out how to find the greatest common factor of those problems that we have below us. Okay? Kashmir, Adea, Jalen, David, Jesse, and James. Go grab them. You guys have about 15 minutes to work on that. Okay? So you guys are using the factor trees, okay? So put each of the 2 numbers on both sides, and then I want you guys to talk about what you guys may have gotten right, what you, if you guys come up with different answers, what you guys can figure out what the issue is, okay? You guys good? So you're gonna be working together, and you're gonna, if there's something that if you guys don't get the same, try to figure out what the issue is. Okay, take good.
And then so figure out what two numbers go into 28. So let's try something like 7 and 3. No, 7 and 4. 7 and 4. So you have 7 times 4.
So if you guys find one that you're not sure about, just talk with it, see if you can come up with it.
And then 56 is
4, no, 6.
Alright, just find a number. Very good. If you come up with different answers,
That's
talk it out, see
54.
what the issue is.
Okay, so.
Let's try
You
7.
can write the answers on there.
No, so.
After you guys come to a consensus, go ahead and write the correct answer on the little slip that you have. Okay? When you guys come to a consensus,
Now we're finished with this one. Sorry.
It's 7.
Oh yeah.
that's exponential. Very good. You're going above and beyond because that's the next step we're going to learn next week. 3 times 3 times 2. Where's your second one?
32. Let's get Four times 8. Yeah.
Okay, now we all have to share 30 and 40. I forgot to use the Ethan, are you ready? Okay, so
16, 12,
They did the same thing, it's still 3.
Remember they share them all.
2 times 2 and 3 times 2. So what do they have in common? A 3 and a 2, right? So the greatest common factor is 2 times 3, which is.
Yeah, you can take.
But make sure you circle the bottom. 6.
You said 2.
So you have 1 3 in common and 1 2 in common. So
Alright, 6.
30 and 48 is okay.
Times 1.
I got 2.
You notice both of them have two.
Oh, I learned it from
Both
my
have 2. How many 2s do they both share?
Okay, let's try to do.
everybody pause for a second. Everybody pause for a second.
1, 2.
One thing I'm noticing is that sometimes you're not circling the prime numbers at the bottom. It helps you to see it better so that you can find factors that both the numbers have in common. This will help you get the greatest common factor a little easier, okay? All right, go ahead and continue.
You said they both have 2. Do they not both share?
I'm finished. It's two. I think
See it, both ends are 0.
So which ones do the 24 and 25 in common? Go ahead and circle all of them.
25.
Yeah, 2. 32.
you're right, right?
How'd you get 4?
6 doesn't go in.
Oh, I think